So what we've seen so far is how to write the ionic formula for ionic compounds between a group 1, 2, or 3 metal and a nonmetal. If you were given a transition metal, the oxidation numbers cannot be found from the periodic table. They can be, but I'll show you how to do that later. But just by looking at the transition metal, there's not a shortcut that we've talked about as to how to find the oxidation number of those. So I will show you how to go about naming ionic compounds or writing the formulas for ionic compounds that have transition metals. The thing that you have to add, or the thing that you have to be able to read, is a Roman numeral. So let's just do a quick review of Roman numerals. Roman numeral 1 is represented with a straight line. Roman numeral 2 is written with 2 lines. Roman numeral 3, 3 lines. Roman numeral 4 is written as IV. Roman numeral 5 is a V. So 4 makes sense because it's 1 before 5, which is 4. 6 is going to be VI, and 7 is going to be VII. So just keep those in mind. If you don't know those, study them, because you will be expected to know what they are on the test without having a reference sheet. So to write the formula for ionic compounds with a transition metal, it's the same rules that we saw yesterday. You write the symbol of your metal and your nonmetal. You write the oxidation of each ion. For the transition metal, though, the oxidation number will not be found on the periodic table. It will be given in Roman numeral in parentheses in the name. Okay, so one, you know you have a transition metal because in the name you'll see this Roman numeral. So that's sort of like a giveaway. And then you don't even need to look at the periodic table because the Roman numeral is given in the name it's given in the name for you. Then you're simply going to drop and swap like we did yesterday, and then simplify the subscripts if necessary. So here, for example, you'll see the name iron 3. What that means is that iron has an oxidation number of +3. Because they are transition metals, their oxidation numbers are going to be positive. It really doesn't matter because the positive signs drop anyway, but just so you know, they are all going to be positive because the metals are always going to lose their valence electrons. Copper 2 becomes copper 2 positive. Lead 4 becomes Pb4 positive, and silver 1 becomes Ag1 positive. So titanium 4 would be Ti4 positive, cobalt 2, CO2 positive, silver 1, Ag1 positive, zinc 2, Zn2 positive, nickel 3 becomes Ni3 positive, and mercury 1 becomes Hg1 positive. Okay, and then after that, it's just a matter of writing the ion for the nonmetal and then dropping, swapping, and simplifying. So here we have iron 3 phosphide. The iron has an oxidation number of +3. So if you go to the periodic table, you will not see an easy bold oxidation number written above iron because it comes from that Roman numeral. The reason that they have to have Roman numerals is that the transition metals oxidation numbers can actually change depending on what it's bonded to. So sometimes iron has an oxidation number of 3, sometimes it has an oxidation number of 2. So for transition metals, because they can change like that, that is why you have to specify what it is with that Roman numeral. Phosphorus is P, which has a -3 charge, and so when you drop and swap and simplify, this becomes FeP. Niobium fluoride. Niobium is Nb with a +3 charge. Fluorine, so the nonmetals, that does not change from what we previously saw. That number still comes from the periodic table, so it becomes NbF3. Zirconium 4, Zr, its oxidation number is +4. Oxygen is -2, so this becomes Zr2O4, which you must simplify the 2 subscripts to ZrO2. Platinum 4 nitride. Platinum is PT. Its oxidation number is +4. Nitrogen is -3. So this is PT3N4. Cadmium 2 phosphide. Cadmium is +2. Phosphide is -3. This becomes CD3P2. Silver 1 bromide. Silver +1. Bromine -1. So this becomes AgBr. All right, let's take a look at these. Silver 1 fluoride. Ag +1. F -1. Becomes AgF. Manganese 4 iodide, its oxidation number is going to be +4. Iodine is -1, so it's MnI4. Chromium, Cr3 positive. Carbide, which is carbon, it's going to be -4, so it's Cr4C3. Tungsten, W +2, phosphorus -3, W3P2. Gold sulfide, Au +3, S -2, Au2S3. So it's just the same as we've been doing, except that this number now comes from the Roman numeral of the metal. Titanium 4 bromide, titanium +4 comes from that. Bromine -1, TiBr4. Iron 3 phosphide, Fe3 positive, phosphorus 3 minus, simplifies to FeP. Copper 1 iodide, Cui. And that is the end of that.